Good evening, everybody, and thank you for participating tonight. So, Defeat Duchenne funded a project in our lab a couple of years ago now where we are exploring a very novel delivery system of a protein called Wnt7a. Wnt7a, as you can see on the left, has a very powerful effect on regeneration in skeletal muscle. It's a natural protein that's secreted during muscle damage that mobilizes muscle stem cells, stimulates their migration, and also acts directly on the myofiber to enhance strength. And we've shown that intramuscular injection of this protein really has a profound effect on muscular dystrophy and makes the muscles stronger and through stimulation of regeneration and acting on the muscle fiber really dampers down the muscular dystrophy phenotype. This protein is secreted, so it acts like a hormone, but the protein itself is very, very insoluble, and you can't inject it into the blood system to go across the body. So the way we're attempting to address that is to make use of the natural biology of this protein. So we discovered that Wnt7a is normally secreted not as a free protein, but is secreted out of cells attached to the outside surface of small extracellular vesicles. These are also called exosomes. So during muscle damage, newly formed muscle fibers secrete these little particles with Wnt7a on them at very, very high levels. And then these travel to muscle stem cells and to regenerating fibers, and in a feed-forward way, really enhance the regeneration process. And you can see on this electron micrographs, here are some of these EVs or extracellular vesicles, and these black dots are Wnt7a sitting on the surface. And we can make exosomes with Wnt7a or without Wnt7a and show that they have that those with Wnt7a have very nice bioactivity at stimulating myofiber growth in a petri dish. Now, the critical experiment, of course, is to do this in mice. So we have to use a very complicated protocol called tangential flow filtration that we developed to purify very pure preparations of these exosomes. We inject them into the circulation in the blood system of mice that have received an injury, and these are MDX mice that have Duchenne muscular dystrophy. But they're also mice that lack Wnt7a in muscle, so that they are a sensitized responder for anything that we inject. Now, normally to see an effect in an MDX mouse, we have to inject 2 micrograms of Wnt7a protein directly into the muscle. Here we've only injected about 700 nanograms into the tail vein, where it goes through the entire body of these mice. And this just shows you the force being generated by this regenerating muscle in the MDX mouse. And we can see a 50% increase in the force generation, really showing that we've accelerated and augmented regeneration, which is deficient in these dystrophic mice. But we also looked in the diaphragm, which wasn't injured with cardiotoxin, and we can see a dramatic difference in the appearance of the muscle. So in the diaphragms and the control mice, we see these big areas of fibrosis throughout the muscle, and we really don't see that in the mice that were treated for Wnt7a EVs. So we're now extending this work by ramping up manufacture of this material so that we can just treat regular mice. But in the second part of the project, we're also engineering Wnt7a so that it has enhanced activity and enhanced targeting specificity. And this is by using 2 different proteins. One part is Wnt7a, and the other part is a protein that will enhance targeting to muscle and enhance Wnt7a activity. And right now we are taking this through a series of biochemical tests to ask whether or not it's behaving in an enhanced way, and it sure looks like it is. And then we're going to move it through all the different sorts of tests to evaluate this. And the notion is that this could become a therapeutic that could be delivered to patients perhaps on a weekly or monthly basis that would then prevent and slow progression of Duchenne muscular dystrophy. So that's the project funded by Defeat Duchenne. I'd like to close with just giving you a very, very short update on the work being pursued by Satellos Bioscience. I should disclose that I'm the scientific founder and I'm the chief development officer, so I'm in a conflict of interest, so you probably shouldn't believe anything I'm saying, but we have some really exciting news. So we've developed drugs that target the Notch pathway that was previously described by Lou, and they really have quite a profound effect in mobilizing muscle stem cells and stimulating regeneration. These drugs now are, and the clinical candidate is moving into phase 1 clinical trials. That's a safety test, which will take place in spring, summer of this year. And by early 2025, we will be in phase 2 clinical trials. This is a very exciting development, and I certainly look forward to having Canadian sites open where we can treat patients in Canada. Thank you.